All right, so ANOVAs are difficult, right? We're going to learn a total of three by the time we're all said and done here. So far, we've learned how to do it between subjects ANOVA. So I thought that I would just make this little video that's very similar to, one of the questions on the homework, right? In fact, at this particular time, you should be able to answer questions 2 and 3 on the homework. By the time we get finished with the next lecture, you should be able to answer questions 1 and 4, which would in turn complete the homework. But I thought I would make this video just to sort of kind of hammer it home here, and hopefully it will be helpful, right? So I've made up a kind of silly scenario here, but it's perfectly fine for sort of illustrating what I want to do here. So an IO researcher investigates the deliciousness ratings, right? So that's going to be a rating between 1 and 10, right, of his company's pop, which is brand A, compared to 2 other competitor brands, brand B and brand C. He randomly assigns 18 people to taste one of the 3 pops and measure deliciousness, right? So, remember that this is a between subjects design. So, he's got a total of 18 people. They've been randomly assigned to 1 of 3 conditions. So you're going to have 6 people in each condition. And the people that are tasting and rating brand A, that's 6 people. The people that are tasting and rating brand B, that's 6 totally different people. And the people that are tasting and rating brand C are also 6 different people. Right? So this is a between subjects design. One group of people, another group of people, another, or one sample, another sample, right? And so, in this case, the first person to taste brand A, gave it a rating of 9 out of 10. Same with the second person. Looks like the third person gave it a 7 out of 10 and so forth, right? Okay, so that's the data. First thing we want to do is state our hypotheses. So, one of the nice things about between subjects ANOVA is the hypothesis testing in terms of stating the hypotheses, the null and the alternative is quite easy, right? Your null is simply the argument that, well, there should be no difference between our means. And so in this case, I've already jotted down, mu1 equals mu2 equals mu3. And what that basically says is, look, sort of as a default position, right, as the null hypothesis, we don't expect there to be a difference in deliciousness ratings for brand A compared to the deliciousness ratings for brand B and brand C and so on, right? In other words, the null hypothesis says if we took this mean and compared it to that mean and compared it to that mean, there would be no statistical difference. Whereas the alternative is just simply, okay, not the null, right? And because we're dealing with at least 3 means here, we can never really make a directional prediction in terms of our alternative in terms of specificity. Look, if this was a real research question, we might have an idea of what mean we might think would be better, would be different or so on and so forth. But when we're talking about statistical notation, we're just simply saying, look, there's going to be a difference somewhere, right? It could be that brand A is better than brand B, which also happens to be better than brand C, right? Or it could be that, the mean of brand A is significantly greater than both the means of brand B and brand C. So the reason why the alternative is just simply not the null is because when we run our F statistic, and if we reject the null, it just simply tells us there's a difference between these means somewhere. It doesn't tell us which one is different, right? So, it's good to sort of understand kind of the underlying thing of what's going on here, right? But it's also helpful to just sort of rote memorize. Okay, how many means do I have, right? Okay, so if I have 3 means, then the null hypothesis is mean 1 equals mean 2 equals mean 3. And by default, my alternative hypothesis is not the null, right? So now we want to define the critical region, right, using an alpha of 0.05, right? So first of all, let's figure out the 2 degrees of freedom that we need, right? So in order to do this, we need the degrees of freedom for between groups, and we're going to need the degrees of freedom for within groups. And even though we haven't done any math yet, right? Even though we haven't done any math, we can do that quite easily, right? Because we can just remember our formulas. We know how many people are in this study right here, and we know how many conditions we have. And that's all we really need in order to figure out the degrees of freedom for both between groups and within groups. The degrees of freedom for between groups, the formula is k minus 1, right? So k is the number of conditions. So 1, 2, 3. So 3 minus oops, 3 minus 1 equals 2, right? So our degrees of freedom for between groups is 2. Our degrees of freedom for within groups is big N, right? Which means the number of all of our participants in the study minus K. So we know we've got 18 people in this study, right? 6 here, 6 here, 6 here, right? Times 3 conditions, that's going to be 18. So 18 is our big N, so we're going N minus K, right? And so what we're doing is 18 minus 3 equals 15. So our degrees of freedom for between groups is 2, and our degrees of freedom for within groups is 15. So now we have to look up the critical value in the table. We're going to do it in an alpha of 0.05. Now I've got a bit of a different table up here than you do because I'm just pulling it off the internet. But the structure of the table is the same way. So just like in your table, for the upper row, that's where we're going to find our degrees of freedom for between groups. And remember, that was 2, right? So that's our degrees of freedom numerator. I think your book refers to it as degrees of freedom numerator, which is the same thing as saying degrees of freedom for between groups, right? So that's going to be 2. We're then going to look in the degrees of freedom for the denominator, right, or the degrees of freedom for within groups. We're going to find 15, right? And then we'll go over and find what our critical value is. So in this case, our critical value is 3.682. So we'll go ahead and write that in. F crit equals 3.682. And if I were you, right, you know, I'm not going to do this with my my stylus pen because I just write like garbage with it. But this is a spot where you probably want to draw that sort of skewed looking F curve that we've done in lecture, right? And you're going to want to label somewhere on that curve where the 3.682 is, right? And you'll know that, okay, well, when we actually run our F test, if the F statistic that we obtain through our calculations is less than this value of 3.682, then we would fail to reject the null. But if it's greater than that, that means it's going to fall into the tail, right, into the rightmost tail, the only tail of the F distribution. And then in that case, we're going to reject the null hypothesis, right, meaning that there's some sort of difference. Now, if you look at your homework, actually, I don't want to go down that far yet. In fact, why don't I just do this? That's annoying. There we go. If you look at your homework, it's going to say, okay, complete the table, right? And by completing the table, by definition, you run the F statistic, right? But you know, don't forget to show your work, right? So you've got to fill in this table, but you still need to show the important sort of aspects of your work. And so I'm going to sort of show you what that should look like. For the sake of time, right? And there's no reason why you can't do this either at home, right? I'm going to copy these data, and I'm going to paste them into an Excel. We're going to do this in Excel. So that's our data right there, right? This is brand A, brand B, brand C. And remember, let me go back to this. Remember, we need a few things in order to let me go here. In order to compute our ANOVA, right? We're going to need G, right? G is the sum of all of our scores. And we have 3 groups, right? We have 3 groups. So we're going to have a T1, right? Which is the sum, T means sum, of all of our scores for brand A. We're going to create a T2. That's the sum of all of our scores for brand B. And then we're going to create a T3, which is all of our scores for brand C. So we're going to need a T1, T2, and when you're doing your homework, you should. I don't expect you to write out, you know, all the little addition stuff that you do, but you should definitely include this, you know, this sort of information, you know, in this part of the homework, right, or wherever you're showing your work by hand. You know, I definitely want to see the G. I definitely want to see your different sum scores for each condition. And then, of course, we also have sigma x squared, right? In fact, you can actually do this in here, symbol sigma x squared. So I need a sigma x squared for each one as well, right? And I'll just copy this. So make sure that when you're showing your work, you know, you've at least written in the values for all these. So let's go ahead and do those right now, because that's what we need in order to do the problem. So I'm just going to sum each row, and you can do that really easily in Excel, right? By clicking the sigma button, right? Not surprisingly, the sigma button means sum. And typically, you know, it'll get everything, like you see right here, it's selected everything in that particular row. So great. So, you know, if I add up all those, if I add up 9 plus 9 plus 7 plus 8 plus 7 plus 7, I get 47. Do the same thing over here. Add up my second row. Add up my third row, right? And also, easy enough, if I sort of put my, select this particular cell, watch what happens when I hit that sigma again. Notice it adds them all across sort of sideways. Well, this actually, right, if I add up all these scores and add up all these scores, add up all these scores, I can just add across to get my G, right? So this is T1, this is T2, that's T3, and that happens to be G. There's also sort of an easy way to do the sigma x squared as well, right? So you got to go equal, you know, select your value in the cell A1, and then if you just square it, right? So 9 times 9, 9 squared is 81. You can just drag these down, right? Make sure that you only drag down, though, through the data that you want to keep, or that you want to actually do this operation on. But let me show you here. So, right, so it's taken the value in A1, which is 9, and squared it. Here it's taken the value in A2, which is also 9, and squared it. Here it's taken the value in A3, which is 7, and squared it, right? So you see how that works. So let's do this for all of them. And again, once you do one, you can just highlight it and drag it down. And now let's do it for the values in C. And remember, it wants us to square each one of these values, right? Square each one of these values, which we've done here, and then it wants us to sum it. So we can hit sigma again, right? We can just keep doing sigma all the way across the board. So if you were to do this in Excel, or you were to do this in your calculator, do I need to see all this? Nah, not necessarily. But I want to see T1, I want to see T2, so on. I want to see G, and I want to see the different sigmas. All right, so let me just get these into our document. All right, so G was 100, T1 was 47, T2 was 27, and T3 was 26. And then our respective sigmas were 373 for the first group, 127 for the second group, and 122 for the third. So now I have everything I need. You know what, actually, while I'm here, even though I've already figured that stuff out, let's go ahead and, what's our big N? That's 18, right? What's our little n? That's 6. And what's our k? That's 3. Okay? So that's absolutely everything that we need in order to do our ANOVA here, right? So let's go ahead and do our between groups ANOVA first. And here, I definitely want you to write out the equation that you're using, right? Because this way I can look at it while I'm grading. And if you've made a mistake, well, I can identify where you've made the mistake. So we're going to compute the sum of squares for between groups. And what we had to do in order to do that was that we had to, for each one of our conditions, right, we had to square each value and divide it by the little n. So we'd go 47 squared divided by 6 plus 27 squared divided by 6 plus 26 squared divided by 6. And then we were going to subtract from that, right, our g squared divided by our big N, right? So let's do the first part of the clause first, right? So let's just go 47 squared divided by 6, right? Plus 27, and again, you should write this part out, right? Divided by 6. This way I can make sure that you're actually doing the right things here. And then finally, 26 squared divided by 6. And if we were entering into the calculator, actually, we would enter it in this way. And then ultimately, like I said, we're going to, whatever that is from that, we're going to subtract g squared divided by big N. But let's do this part of the equation first, right? So let's just go ahead and do it in Excel, right? So let's just go, I'm going to make this sort of easy, right? I'm going to go, I'm going to figure out all my square roots first. Or not my square roots, my squared values. So I'm going to find 47 squared, which is going to give me 2209. Then I'm going to find 27 squared. Where's my, there it is. It's going to give me 729, and then I'm going to find 26 squared, which is 676. And remember, I'm going to divide each one of these by little n, right? So 6, 6, 6, right? And so right underneath here, I'm just going to finish the equation. So what I'm going to basically do is go 2209 divided by 6. All right, and I'm going to keep doing that for all of my conditions. Now I'm going to go 729 divided by 6. And now I'm going to go 676 divided by 6. And I think it's a good idea to sort of show what's going on here again if you're showing your work, right? So I'd say, okay, we're going to go 368. We'll round it to 0.17 plus 121.5 plus 112.67. And so now I just want to add those up. Now when I do that, so I'll go ahead and round it to 602.33. Okay, now remember, we've done this in class. We're not done here. This isn't our sum of squares between groups because we still got to subtract from this value g squared divided by big N, right? But for now, we figured out everything that's on the left side of the equation. And if you're confused about this, all the slides are online. You can look at the equations. You should have them in your notes, and they are in the textbook. So let's go ahead and figure out the g squared, right? Which is, so the way this, it's going to be 100 squared divided by 18. And let's just go ahead and do that in Excel. So 100 squared, oops, no, I don't want that. 100 squared, right? And what's our number? It's 18, right? So we're going to go, so that 100 squared is 10,000. So we're going 10,000 divided by 18. And that gives us 555.56 if we round it up, right? So then I'd say equals 555.56. And so remember, our actual equation for sum of squares between groups is just, you know, this clause that we've done minus this clause that we've done. So to finish this up, right, we're just going to go 602.33 minus 555.56, right? And so we'll do that in Excel, right? So 602.33 minus 555.56. And so that's our sum of squares. Our sum of squares is 46.77, right? Equals 46.77. Fantastic, right? And look, we can go ahead and add that into our table. 46.77. I don't know why that's underlined. I don't want that underlined. There we go. And while we're here, we might as well fill in our degrees of freedom, right? We knew that that was from before. We figured that out. That's 2, right? Awesome. Okay, now let's do our sum of squares for within groups. And so remember, for within groups, what we had to do is essentially just figure out the sums of squares for each one of our individual conditions and just add that up. And remember, what's our sum of squares equation? It's nothing more than sigma x squared, right, minus t squared divided by little n, right? So for the first condition, right, we go 373 minus 47 squared divided by 6, right? And I think we've already sort of done this, haven't we, right? So here's we've done some of this, right? So you can, again, think about these as sort of two clauses, right? On one side of the coin, you have sigma x squared, which we've done already, right? And then on the other side of the clause, you have t squared divided by little n, right? Well, let's go back to our Excel sheet. So this is one of the nice things. What is this? Well, let's go back. We've already done this step, right? Note here that I'm going 47 squared. Well, what's 47 squared? 47 is t squared, right? This is t squared. And then if I divide it by little n, which is 6, I get 368.17, right? So we've already done some of this. So all we really have to do is take these values, right? So for our first group, we can go 373 minus our t squared divided by n value, which we already figured out at an earlier step, right? So we'll say 368.17 if we round it up, right? That's 4.83. What's our next one? Here we have a value of a sigma x for our second group of 127, right? And so we're going to go sigma x squared, right, minus our t squared divided by little n for our that we figured out at the previous step, so 121.5. And then we're going to do the same thing for the last condition. Sigma x squared minus 112.67. And now all we need to do is sum these up. All right, we get 19.66. We can put that in our table. And we also remember, right, that we had and that being said, I'm getting ahead of myself though. If I were showing my work, SS within groups, what I would do is I would do this for each one, right? So I'd go 373 minus 3, so you want to show, you don't have to show necessarily every single step, right? But you do want to show, so I guess I don't even need the parentheses. You do want to show enough so that I can easily figure out if you made any mistake or where you made the mistake, so I can give you some guidance. They're the same, right? So now we're going to go 127 minus 121.5. That's going to give us 5.5. And then we'll do it for the last one. So this is, again, this is all the sort of level of work that you really need to show here. And then I would just do this equals, what did we say it was again? I've already forgotten. 19.66. Great. So I've computed my sum of squares between groups. I've shown the appropriate amount of work. And I've done the same thing for within groups. And now I can start filling in my table. And so remember, our degrees of freedom for within groups is big N minus K. So that's 15. Cool. So now I can finish out my table here. And all you need to remember is that your mean squares is going to be derived, right, from taking your sum of squares and dividing it by your respective degrees of freedom. So the mean squares for between groups is going to be 46.77 divided by 2, right? So let's figure that out right now. 46.77 divided by 2. So that gives us 23.39. We'll go ahead and round it up. 23.39. Again, not sure why this is underlining, but now we need to figure out our mean squares for within groups. That's 19.66 divided by 15. So 19.66 divided by 15, and that's just 1.31. And then to figure out what our F value is, we're just simply going to take our mean squares for between groups, divide it by our mean squares for within groups, and that'll give us our F statistic, right? So we're going to go 23.385 divided by 1.31. So we get a huge F value, 17.84. Cool. So now we're done filling out the table. We've shown all the work that we're required to show in order to get full credit, right? Ideally, we probably would have drawn our F distribution over here, and it's an absurdly large F, right? I mean, it's crazy large. But we can already compare this F value that we obtained to our critical value. And what do you think our decision is going to be? It's going to be to reject the null, right? Because, here I can make this big again. Because, right, this F obtained is far larger than this F critical, right? And if we had plotted this on a curve, right, or like it's way, as close to as far to the right as you could practically possibly be, right? This is a crazy big F value. Okay, fantastic. So we reject the null. If applicable, we want to compute the effect size, right? And so the effect size is nothing more than, oh, look what else I forgot, right? I'm actually supposed to complete this table. We talked about this before. I can figure out the sum of squares total by adding my sum of squares between groups to my sum of squares within groups. So let me do that one step really quick, right? So we'll call this sum of squares total, which we'll get by adding 46.77 to 19.66. And what is that? I'm going to have to do that in Excel. 46.77 plus 19.66. That's going to give me 66.43. So I need to put that in my table. And then our sum of squares total, our degrees of freedom total, rather, is big N minus 1. So we had 18 people, so 18 minus 1 is 17. Okay, so let me go back. Now our table is truly complete, and we get 100% on it. So now I need to compute the effect size. That's what drew my attention, the fact that my table is incomplete. Remember, the formula for effect size when we're doing a between groups ANOVA is the sum of squares between groups divided by the sum of squares total. So it's going to be 46.77 divided by 66.43. So 46.77 divided by, I already forgot. So it's such poor working memory. 66.43. So let's do this in Excel. 46.77 divided by 66.43. And so it's a partial, it's an eta squared. It's an eta squared of 0.70. Right? In fact, we should be able, I think this has got an eta symbol in here somewhere. Let me see. Should have it. I don't know. I'm not going to search around too much for it, but it's not that. There it is. That's the eta symbol. Oops. Right, so you actually could just do this. Eta squared equals 0. And so, the book, or not the book, but the, we've been talking about interpreting this in terms of Cohen's d, and, it's good for now. It's sort of an awfully simplistic way of interpreting it. One of the things that we're going to talk about in the next chapter is that this can also be explained as sort of a proportion of variance that's explained by the difference between your groups, right? So what this is saying is the difference in scores between my three groups, wherever my actual difference lies, that accounts for basically 70% of my overall variability, right? It's something that we'll talk more about, I think, starting in the next chapter, or maybe it's the chapter after that. This idea of proportion of variance explained. But for right now, it's sort of a simplistic way of interpreting it, but we can say this is a pretty good effect, right? It's a pretty good effect. All right, fantastic. So now, if applicable, compute two keys. And you'll note that, in the homework, I've already sort of computed two keys for you, and you're just asked to do some interpretation. But I think, this is still worth sort of going over. So we're going to go ahead and compute two keys from scratch here as well. And so the first thing we need to do is use a different table. And here again, just one I pulled up from the internet. But it's the same table as yours, it's a little bit different. Remember now, in the top row, we don't want k minus 1, but we actually want to find the column for k, right? Our number of conditions is 3. And then we want to match that up with our degrees of freedom for our within groups, which was 15, right? And that's going to give us a q value of 3.67, right? So I'll say, okay, q equals 3.67. I also need my mean square within groups in order to do this. And I'll go back up to the table to get that. My mean square within groups is 1.31. And then I also need my little n, which was 6. And so the equation for this, a little complicated, it's q times the square root of the mean square within groups divided by little n, all right? And I think I can just copy and paste this into Excel. If I put a equal sign in front of it and then paste it in there, it should run it for me, and it does, right? Okay, cool. So this gives me a two keys of 1.714. We'll just say 1.71. So now what I need to compute my means for each one of my groups, right? And then subtract them all from each other and see if I take the absolute value of those, which ones are greater than this two-key score of 171. So I'm going to go ahead and compute the means. Excel has a function for that. It's called average, right? So you can select average. And again, be sure to only take your scores. You can do it for all three of your groups. And how many combinations do I have here? Let's say I have A minus B, A minus C, and B minus C, right? So first let's take A minus B. So we'll just call it 7.8 minus 4.5. That's a difference at 3.3 for A. And so again, this is A minus B, right? So for A minus C, we'll go 7.8 minus, so we'll just call this 4.3. Again, so that's A minus C. And now let's figure out B minus C. That's going to be 4.5 minus 4.3. And I've kind of made a mockery of my organization here, right? This was my two keys that I computed. Yeah, it was. I probably should, I should have done this more cleanly, but I was just sort of being lazy. Okay, so that's two keys. So what I want to do is I want to compare, got to put the equal sign in front of it. What I want to do is compare the absolute value of each one of these to this two-key score here, and that'll tell me which one of my means are different. So 3.3, is that greater than our two keys of 1.71? It is, right? So 7.8 is larger than 4.5, right? So that means the rating for A was greater than the rating for B. Let's look at A minus C. So 3.5, that's greater than 1.7. So the mean for A was greater than the mean for B. And then let's compare mean B and C, 4.5 to 4.3. Note our value that we get is 0.2 for our difference, which is much less than our two keys of 1.71. So it looks like A is greater than B, and A is also greater than C. Right? All right. So now it's telling us to state our results in APA. We reject the null hypothesis. The between groups ANOVA showed a significant difference between the 3 brands of pop. Okay, so now we want to report our statistics. F, and then, and then in parentheses, our first value should be our degrees of freedom for between groups, which is 2, comma, our degrees of freedom for within groups, which is 15, equals whatever our F statistic was, all the way up here, 17.84. Right? Then P, because we've rejected the null, it's going to be less than 0.5. And then finally, we need to report our eta squared. I'm just going to copy and paste this. And I'm going to be sort of anal retentive about this. P should be in italics, and F should be in italics. And then this is followed by period. And so remember what I told you before, we want to go ahead and do our little sort of descriptive sentence about sort of where our differences are. We're going to need our standard deviations for that. So believe it or not, Excel happens to have a function for standard deviation. It's just stdev, right? So again, we'll just select what we're looking for. And now we can, I'm going to minimize this while I type this in. And now we can finish writing up our results. So what we're going to say is participants rated brand A, and then we'll report the mean, which was 7.8, in parentheses. Mean equals 7.8, comma, standard deviation equals, we'll just say 0.98. Rated brand A, I don't know, better. It's better than brand B. And then let's report brand B's mean, which was 4.5. And brand B's standard deviation was, we'll call it 1 point, we'll round it up to 1.05. Better than brand B and brand C. Also report that mean 4.3, standard deviation of, we'll round it up to 1.37. And then we're not done here, because now we have to say there was no significant difference between brands B and C. Now note that I don't have to report the means and standard deviations again for those, because I've already done it up here. And again, if we're being really anal retentive and APA about things, we would italicize the M and we would italicize the S, right? Same thing for these other two. You know, this is less of a problem for you for this class, but it is going to be a big problem for you in the next class, right? Because, you know, doing all the things right in APA format is a huge part of research methods, and you will lose points for not doing it correctly. And there it is. I've just demonstrated it for you, the perfect way of writing up a between subjects ANOVA, right? So it looks good to me. So, you know, that's a bit of a long video, but hopefully it was worth it for you guys. You know, you get a chance to sort of see, you know, at home, you can, you know, pause it and rewind it and all this other good stuff, sort of what I've done step by step. And again, while in the homework, you're not going to be asked to compute the two keys, right? You are still going to be asked to compare, you know, the differences between your groups to the two keys value that I actually give you, right? So, so that's that. Hopefully, like I said, this was helpful. If you have any questions, let me know.